Day 20 quiz material. All right, so this is when we started factoring. And the first thing that we're going to talk about is when A is 1. Which we've done a lot of. Yay. Factoring when A is 1. All right, so that looks like this. X squared minus 14x plus 48. So this is what we call the X method. We look for two factors of 48 that will add to a negative 14. So just a couple of things about the signs here. When this is a positive number, it's either going to be a plus plus or negatives, yep. And it's going to be the same as whatever sign is down here. So for our example, this is a positive, but down here is a negative, so that tells me I'm going to use two negative numbers.
It's 6 and 8.
Yep. Sayer says negative 6 and negative 8. So when I factor this, it's just x minus 6 and x minus 8, and I'm finished. Recently, we were solving by factoring, which actually we're going to talk about tomorrow. But I know I don't have to solve because this is not set equal to 0. They don't want me to go further. So I would just stop right here. All right, number 2. Let me get one where there's a negative, positive. All right. X squared minus 3x minus 28. So we'll look for factors of negative 28 that add to negative 3. So as a reminder, when we have a negative on top, we're going to have opposite signs. And whatever sign this is going to be the sign of the bigger number.
It's 7 and 4, and the 7 is negative, I want to say.
Yep. 7 and 4, Sayer says, and he says that the 7 is going to be negative. And the 7 is negative because since down here is negative, then the sign of the bigger number is going to match that. So x minus 7, x plus 4. I feel like you guys should be pretty comfortable with this type of problem. We've been looking at them. Okay. The next type of factoring we'll look at is when A is greater than 1. When a is greater than 1, it's going to cause us to have a couple of extra steps in the process. Let's see. All right. 5x squared plus 17x plus 6. So if I were to try and find factors of 6 that add to 17, I would not be able to be successful. That wouldn't make sense. Since it doesn't make sense, that would trigger to me that there's more to this process. So the part that is more is I have to also include that a now. 5 times 6 is going to go at the top of that x. So we're going to use factors of 30 that add to 17. So factors of 30 are 1 and 30, 2 and 15, 5 and 6, 3 and 10. Which pair of numbers would we want to use? 15 and 2. So in this process, we keep 5x squared and we keep plus 6, and we're going to rewrite 17x using 15x plus 2x. So I'm not changing the math, I'm just kind of rewriting things. And I'm putting the 15 by the 5 because I know that they'll have something in common. And then I'll put the 2x by the 6. I think what we found is that it was easier to put the bigger number here usually. I didn't realize that pattern until somebody had mentioned it. Okay. So we split it down the middle. And we look for the common factor. On each side. So I'm looking for a number that I can divide out of 5 and 15. What can I divide each of those numbers by?
3.
3 is going to be what's left, but what am I dividing out to get that 3? Yes.
What? So you don't want to do for both of them?
Yeah, I want to divide it out of both of them.
Oh, I thought you were talking about both sides.
Oh no, yeah. I'll use a 2 over here. The 3's coming.
Okay.
Your mind was a little too fast. All right, so I'm going to divide a 5. I'm also going to divide an x out of this front one. You always get an x in the first one. So after dividing, I would get 1 x plus 15 divided by 5 is 3, and x divided by x would cancel. So there's your 3. On this side, 2 and 6 can be divided by 2, both of them. So I put that common factor in front, and I divide out 2 divided by 2 is 1x, plus 6 divided by 2 is 3. The parentheses here should always match. So I write 1 of the match. write one of the match, and then the other one is going to be the 5x and the plus 2, the GCFs. I put them in a different set of parentheses. Y'all want to do that again? Sounds like a creepy smile. Would y'all like to do that again? Is that a yes?
Yeah.
Okay. Let's do it again. And again, 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 again. All right, number 4. Okay. 3x squared. All right, 3x squared plus 14x plus 8. I won't be able to find factors of 8 that add to 14. So that's what tells me I'm also going to use that first number, 3 times 8. So we need factors of 24 that add to 14. Is there a pair of numbers that multiply to 24 and add to 14? One and 24, 2 and 12, 4 and 6, 3 and 8, give me some numbers.
Are you asking just for one?
Anybody?
Okay.
12 and 2. So I keep 3x squared. I keep plus 8. And I rewrite 14x using 12x plus 2x right here in the middle. Sorry, that plus sign's like not quite where I want it. I split it down the middle. And I look for what they have in common. So what can we divide out of 3? Oops. What can we divide out of 3 and 12? 3. And I can also always divide out an x on this first one. So we'll divide out a 3x. That'll leave me with 1x plus 12 divided by 3 would be 4. And the x's will cancel. Out of 2 and 8, I can divide a 2. So I'm left with 1x plus 4 again. And I'm looking for, my mind is looking for these parentheses to match. It's on the lookout for that. So I write one of those. And then I write one of the common factors. 3x plus 2. I promise you this is brain food. Like, nobody is going to ask your brain to do these things besides probably me. But so we went to this place, this Pine Mountain Gold Museum something, and it was a train ride through some lights, some Christmas lights. It was some holiday for the kids. So our tickets were for at 6 o'clock, and we get there and it's like 6:05 because my naughty little nugget wouldn't put his shoes on. And so we get there at 6:05, and I show the guy the tickets, and the guy at the ticket booth is like, "Oh, we're booked until 8:45. You've missed your train." And I'm like, seriously? Like, I've got my sweet little children all bundled up. They're ready to see Santa and some Christmas lights, and you can't fit us on one of these little trains? Like, it's that serious? And it's like this, little podunk thing. It's not like, I don't know. It's not like we missed the Polar Express. But anyway, so, he was like, "Sorry, we're booked." So my husband and I were like, okay, well, we'll just like walk around and hang out. And we meandered down through all of the lights to the train station. And, we told the train attendant, like, "Hey, we missed our train. Like, can we just like hang out until there's room on the train for us to just hitch a ride if somebody else doesn't come?" And she was like, "Sure, no problem." And I'm like, I don't think that ticket guy took Algebra 2. He had 0 problem-solving skills. So if you're ever in customer service, I know that you probably won't be doing Algebra 2, but you will have to problem solve. And I feel like this helps your brain find solutions to not only mathematical problems, but just to life problems. Right, people? That's why we're here. We're figuring out life's problems. And we're also comforted by the fact that there's always an answer. Right? Like, I'm not just asking you like theoretical questions about life or points of view. Right, Carl? He's not even listening. Okay. Do you need to see this again? I was trying to talk to you. It's okay. Are you working on your English?
Yeah, I got 2 more questions.
Yes. We're trying to get Carl through English. All right. So here we go. This was the last topic, and we've actually seen this topic here recently. This was factoring. Difference of squares. So difference of squares problems will only involve certain numbers. 1, 4, 9, 16, 5, 6, 7, 8, 9, 10, 11, 12. Oops. So we saw factoring difference of squares. We also saw factoring difference of cubes. Are you dancing?
No, I'm sorry.
Shauna getting rowdy. We saw factoring difference of squares. We also saw factoring sum and difference of cubes. So we've seen some special numbers this semester. Right now we're going to talk about the squares. So we started out with some easier problems that looked like this, like x squared minus 36. So you could think about this as factors of negative 36, oops, that add to 0. 6 and negative 6. I also called these the evil twins. One is good. One is bad. But then we also saw some problems where they had a perfect square in the front. We haven't seen that as recently. So, like 9x squared minus 49. I would not typically try to put that in an x method because technically that is 9 times negative 49, blah, 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 rewrite the middle.
Wouldn't that be, 3x minus 7 and 3x plus 7?
Yes, so Sayer says, wouldn't that be 3x plus 7, 3x minus 7? And absolutely, that is what it would be. And he's getting that 3 from splitting the 9 into its pieces. So 9 is 3 and 3, x and x, 7 and negative 7. So we just make sure, since these are evil twins, that everybody gets a little bit of each piece. Would y'all like to see that again? All right, this was quiz 20. So if you did not take quiz 20, I need you to take that now. Or if you scored below a 70 and you would like to retake it, you are